All right, I want to go on to 10.2, and we're going to be talking about faces, edges, and vertices of solids. We talked about this in the last section, and maybe I wasn't supposed to yet, but we're going to be looking much deeper into how they work and how they interact in this section. So basically, every shape has faces, edges, and vertices, except for, of course, the sphere. Has faces, edges, and vertices. I should say every 3D shape, except the sphere. And we're going to take a look at a quick example, and we're going to do some labeling of where these things are on the shape. So let's rebuild that cube that we had last time. Not bad. And we have our faces, edges, and vertices. Okay, so let's see. We talked about faces a little bit. Let's talk about these edges. The edges here are the pieces that kind of connect two faces. So it would be these lines here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of those would be the edges of the shape that we are looking at. Every time a face meets another face, we get an edge. As far as vertices are these corner bits. So 1, 2, 3, 4, 5, 6, 7, 8. And these would be the vertices that we have as we are labeling out there. And then our faces, let me see if I have another color because I'm running out of room. I'm not sure if this pen will work. Let's see, test it. Should be okay. Our faces are these edges. So if I were to kind of color them in, it's a little difficult to do with so much color going on, but each of these faces, the flat section is our face. And we have 6 of them in this case. Just like if you ever rolled a die, obviously dice go up to 6. Our edges, how many edges do we have? 4, we had 8. And our vertices, we had 1, 2, 3, 4, 5, 6, 7, 8. I don't think we had 8 edges. How many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had 12 edges. And that's what we're going to be using to sort and kind of build these different shapes that we're looking at. And we're going to be able to use some of this information to quantify and classify them. Let's build a little table. And we've got the names that we have. We have the faces, the number of faces, number of edges, and the number of vertices. So first we have our sphere. And just like we said before, it does not have any faces, it does not have any edges, and it does not have any vertices. And remember, that's because the face doesn't count because it's bent. We have our cone. Our cone has one face. Remember, it's on the bottom. But it has no edges because with only one face, there can not be a space where another face meets. And no vertices. We had our cylinder. And on our cylinder, we had 2 faces, one at the top and one at the bottom. But because they didn't meet, we had no edges and no vertices. We also talked about that pyramid. And we had a couple different pyramids to do. So we need, with the number of faces, we need at least 4. So I'm going to say at least 4. So that means greater than or equal to 4. And with our edges, at least 6. And again, with our vertices, at least 4. Sorry. And we also had those prisms. And we can have a lot of prisms. There's a lot of different kinds. So again, here we need at least 5. We're going to have at least 9. And at least 6. So you can see they're going to be building up much higher. Now with these, I do recommend drawing them out if you're going to be having some trouble figuring out what is what exactly. But the biggest thing to remember is that faces need to be flat, edges need to touch where faces combine, and vertices are where those points are. You're going to be counting and classifying, and I don't think this is going to be too hard, but it's going to be kind of a little different than we've had before. Go ahead and get started, and good luck.